the goal today is to draw some polygrams in the coordinate plane and find the lengths of the sides of those polygons. We're trying to hit the target that says I can draw polygons in the coordinate plane, given coordinates for the vertices. I can also use coordinates to find the length of a side, joining points with the same first coordinate or the same second coordinate. And then I can apply these techniques in the context of solving real-world and mathematical problems. All right, so let's get started. Let's look at example 1. The vertices of this quadrilateral that's in this on this coordinate grid are these numbers right here. And it says draw the quadrilateral in a coordinate grid. Okay, simple enough. Couple things to keep in mind. When you're writing the coordinates, the order of the coordinates is x first, y second. Couple things that I do to keep things organized in my head is to remember which one is the y-axis, because it's not always labeled, is that sometimes I can write the letter y like this. And so it has this long line here, and so I know the long line here is my y-axis. To remember how they go in the parentheses, a good key is x comes before y in the alphabet, so x is always first. Also notice when you're labeling vertices, they should all be capital letters because we're not putting variables in there. We'll find out the answer for those letters, but they're not variables. Okay, and again, just like in here, after you plot the vertices, connect them in order to draw the polygon. I would like you to draw a quadrilateral using these coordinates. Then you can click on this square to check your answer. When you're done with that, please do the on your own. Check your answers in the book and come on back. Key idea. It says finding distances in the first quadrant. We are only dealing with one quadrant right now. Quadrant would be if you had a grid. Let me insert a grid here. And it was split into 4 parts. So let's see. Let's do a grid. And I don't know if this is already done or not, but let's take a look. All right, let's make this a little smaller and put it over here. Okay, so if I took this grid, and I'm guessing here in the middle, I'm not going to count it, but I did this, and again I'm eyeballing, so let's do this. Should be pretty close. Okay, if I could have moved that middle one, but you've got 4 grids. This is the first quadrant, second quadrant, third quadrant, fourth quadrant. So right now, if you really had to visualize the whole picture, we're only doing 1 quadrant. Okay, so we're just doing this little area. Eventually, you'll be able to add all these together. But it says you can find the length of a horizontal or vertical line segment in a coordinate plane by using the coordinates of the endpoints. Endpoints, right here. Whatever those coordinates are, that's what you're going to use to figure out the length. When the x coordinates are the same, right here, this is one's in the red, D and D, the vertical distance between the points is the difference of the y coordinates. So D and D are the same, you can't change that. So actually the difference in the line, and not these two, sorry, they're completely different. In the red is going to be F minus G. Always put the higher one first. When the y coordinates are the same, the horizontal distance between the points is the difference of the x coordinate. So B is the same here. Now we're going to take A minus C, but notice in this problem, whatever this variable is, it's higher than A, so we have to do C minus A. All right? Basically what they're saying is, in the example that they give you, If the x is the same, you only have to subtract the y. If the y is the same, you only have to subtract the two x's. And that's how you find the difference. All right, let's go on to the next one and see what they're telling you to do here. Finding a perimeter. So the vertices of a rectangle are F, 1 and 6, right here, H, sorry, skip G, G, 7, 6, H, 7, 2, and J, 1, 2. Notice, it cannot cross because that would not be a polygram. So you need to make sure it goes in a square. So here's what we do. You draw the rectangle using the dimensions, which they did. Then the length is the horizontal distance between here and here, which is the difference of the x coordinates. Notice a 6 and a 6. So all we have to do is use the x coordinates. 7 is higher, so you're going to do 7 minus 1, and that gives you 6 units. Then you have to find out the width, which is the vertical distance between G and H, right here, G and H. Now that's the difference of the y coordinates. X is the same, y is different. In this case, you can do 6 minus 2. Now you have that. The perimeter then, using the distributive property, you have 2 6s because you have 2 horizontals, and then you have 2 verticals, so you have 2 times 4. You add those together using the distributive property, that's all they're doing here, and making it 20 units. Notice your study tip. You could have used J and H or F and J, because these two are the same and these two are the same. Moving on to example 3. Real life application. In a grid of the exhibits at a zoo, the vertices of the giraffe exhibit are, and they give you the coordinates, which are right here. These are your coordinates and labeled. The coordinates are measured in feet. What is the area of the giraffe exhibit? Now we're taking everything we learned in this chapter and putting it together. It says plot and connect the vertices using a coordinate grid to form a trapezoid. So you plot your points, connect them, and then you look at the shape you have. You have a trapezoid. So you're going to use the coordinates to find the lengths of the bases and the height. Base 1. Base 1. Using what you have here is going to be 60 minus 0, which equals 60. All right? Then base 2, your 30s are the same, so you're going to have 100 minus 0, which is 100. And the height, again, remember, straight perpendicular line, you have 90 minus 30, which is 60. Now you have to come up with the formula for a trapezoid. Okay? My preference would be that you write out excuse me, that you write out the formula, which would be A equals 1/2 height, and then in parentheses, B1 plus B2. Then go into placing in your variables. So you have 1/2 the height, which is right here, which is here, 60, plus base 1 and base 2. Once you figure it out, you have 4,800. So the area of the giraffe exhibit is 4,800 square feet. Please do the on your own and come back for the answers. The one thing I could I ask that you do in the on your own, make sure you have any formula using, or any formula that you're using, you list all the steps. If you're not sure on what steps should be listed, come see me and we'll look at it. Number 5, you should have made a coordinate grid and your answer should have been 15 units and then 11 square units. Of course, 15 units is the perimeter and the area is 11 square units. And number 6, let me read it here. In example 3, the giraffe exhibit is enlarged by moving vertex F. Okay, how does it affect the area? The area increases by 600 square feet for a total of 5,400 square feet. If you did not figure that out and you were not that specific, please go back and write out the steps. And that is the end of chapter 4.